actual results here. For that, let's just briefly say what kind of models are we doing. This used to be state in the art back in the day, long ago. It's an LCM-based model. We do this over characters. We do this using BPE. We do this using BPE, but more merges. And you might be like, oh yeah, how do you select merges actually? This is a really fun thing that I did in the beginning of this project, was like, how many merges are actually best for each language? And so what I tried was like taking different number of merges here given as a percentage of the overall number of types from 0 to 100%. How good is performance when we take that many merges? Train on that many merges and evaluate on that many merges. So every point in this is its own language model with its own test result. And yeah, not doing any merges is kind of bad because it's just a bad way to do character level modeling essentially. And we can see some interesting things like for some languages, the best thing only appears later on, so we need to merge as much as possible. Whereas for something like Hungarian, it's better to not merge as much and keep splitting some words, which I thought was kind of cool to see. We also already see that, you know, Hungarian is kind of hard because lower is better. The language model is less surprised by our language. That's a good thing. But anyway, this is to show that things are different per language. If we average them, I was like, yeah, you know, this seems probably fine. And I'm just going to use this for the rest of my experiments. And before you crucify me for that, take a look at this plot. There is a difference between the BPE that is best for each language individually using this kind of tuning and just using 40%. There is a difference, yes, but it's a way smaller difference than between BPE and characters. So this is going to be a plot that just really shows the difficulties. Most difficult one at the top, least difficult one at the bottom. We can get into the results on the next slide. But this is just in case you were wondering BPE. Okay, so let's see, what are the results? This is going to be the big slides with lots of things going on. The plot that we want to look at first is going to be the one for the Europol data. So this is only going to be 21 languages. This is going to be very, very easy to see, hopefully. The x-axis is going to show the difficulty with the BPE level model, and the y-axis is going to show the difficulty with the character level model. So this kind of cuts the space of languages into two subspaces, one with languages that are easier to do with characters, and one with languages that are easier to do with this kind of BPE. And we hope that the languages should fall along the diagonal, like it shouldn't matter that much. And we see that if we put the languages in there, yeah, they kind of fall on the diagonal somewhat, but not perfectly, okay? So one thing we can see already here is that, yeah, German is harder than English, no matter how you dice or slice it. It is harder with a BPE level model, it's harder with a character level model. That seems like a pretty clear statement. And now going from this to the Bibles, there's going to be a whole lot more points appearing. What I'm going to do before I put these points in there, though, is show you this. What's going on here? Why are there suddenly multiple Germans and multiple Englishes? Someone put it in the chat. What's going on? Why do we have 4 Englishes and so many German points? Why are they all different? No idea. Yes, love that. Yeah, that's right. It's different translations. So for the Bible, one of the beautiful things is that for languages like German and English, we have a number of translations of the Bible, which in theory should have exactly the same information. But in practice, translators kind of take some liberties and they might use different styles. Maybe they use like an old orthography or something like that. Again, everything is contained per Bible, so there's no cross-contamination, but it is still very interesting to see this much variance in the results. And so this shows us that if we only had one of those Bibles, like, sure, we probably can make out still that German is harder than English, but there's a lot of variance in these results, and there's a lot that happens in translation. So while translations are good, they're far from perfect. So that was really cool to see. Now I'm going to put in all the other languages, and suddenly, yeah, there's a lot of them. The rankings between the European languages and their counterparts in the Bible are somewhat stable. Like, yeah, German and Hungarian are hard. Okay, English and Lithuanian are easy. And things kind of fall along the diagonal, but you now have a sense of the variance that's in there. So you shouldn't put too much trust in any individual result. One thing that I want to bring up, because it was on the slide, Mandarin Chinese. much easier with characters than with BPE, which makes sense. Like BPE on top of Chinese characters seems like it's just going to be asking for trouble, especially when we want that many merges. So this is the main results of that paper. Well, not really. We really wanted to do something else, right? We really wanted to figure out what correlates with difficulty. What is it about these languages that makes it harder? Yeah, also for the question, different German dialects, I bet they exist. I bet they exist. In a historical sense, surely there are different ones, right? There's like Luther's Bible and the more recent translations. But I mean, this is far from all the translations that exist. I've seen more translations of the Bible in my life. It's just what we could get our hands on easily enough. All right, so let's ask then, what corresponds with the difficulty? Who's the culprit? One thing, kind of the first thing we thought was like, all right, well, what about morphology? And so we take this measure of morphological counting complexity, which really is just like how many different slots are there in each paradigm, how many different inflections can a given stem take? And you see that like, yeah, Finnish and Czech are kind of very morphologically rich, but I really don't see any correlation between this and difficulty. So I'm going to call that one a nope. In previous work, a paper we had before, we said that there was one, but that was because Finnish was really hard in that paper for some reason. So that's a bit weird. This stuff is hard to replicate in that sense, unfortunately. Okay, well, what about some other linguistically motivated regressors? What about using the walls feature for morphology? Nope, nothing there. What about subject-object-verb order? Maybe? No, nothing there. What about head part of speech entropy? This was like some metric someone proposed for morphological complexity, and it corresponded well with parsing difficulty. And we were like, hey, this could be something, right? Nope. Also no correlation, or at least, yeah, none that was statistically significant. What we did find, however, was if we look at average dependency length, which we hypothesized ought to really make things difficult for a left to right model if the dependencies are very long, that should correlate, right? And I want to say it did, and it would have been significant had it been the only thing we had tested. But since we tested all these different hypotheses, we of course have to correct for that. We correct with Benjamini-Hochberg procedure, and then it's no longer significant. So if you wanted to try and reproduce something, try that one. That one might just work. It's not strong enough for us, but it might just work. And again, one of the issues with this is that we need good parsers for this, so we can only do this on the Europarl languages. So that's really disappointing. It gets worse though. We did find some things that are very predictive. So for one, the character level language model's difficulty is very strongly driven by just the raw sequence length, just the number of tokens. And so for the character level model, that means just the number of characters. So there seems to be something in there that does actually make Putsch easier than German Putsch, just because there's fewer individual predictions. So we hypothesize maybe it's because in every softmax, you are leaking probability mass, and maybe that hurts the model. It's a bit unclear. The second thing we hypothesized at the time, or sorry, we saw at the time, was that the raw vocabulary size, just the number of types, still affected the BPE difficulty. And I was like, whoa, it goes through BPE? I thought BPE was supposed to correct for that. That's insane. And literally just as I gave that talk at ACL, I realized, oh shit, no, I think we messed up. Because we took BPE at 40% of the vocabulary. Well, of course, there's going to be information retained about the original vocabulary. That's not surprising at all. So take that one with a grain of salt. So this is it for correlations. Wow, that was really disappointing. Does anyone else hate this field? Yeah, me too. We are, however, going to have something else in the talk that is hopefully a bit more fun, that I found a bit more interesting at least, and that is that question of translationese. So what's translationese? Well, the idea is if I give you a text in one language and you translate it into another language, then your translation is going to look different from what text natively written in your language might have looked like. Because your translation is going to retain some of the Englishness, it's going to be a bit awkward, it's going to sound like, yeah, like you just wrote a translation. So that's what translationese is. And it commonly assumed that it's easier than native text, simpler perhaps, less complicated, less intricate. And so we wanted to put that to the test, you know. Again, the same paradigm. If we train a model on Translationese versus on native text, which model is going to do better? And so the way we do this is we construct this partial data from the European Parliament data, because Europarl tells us which language a sentence was originally spoken in. So, you know, the first two sentences might have been spoken in English originally, the second one spoken in German originally. And so that's what we're going to be using. And so now you see why we have this partial matrix coming up, why we did this fancy model in the beginning. And if we take the models that we trained the first part of the talk, and now we evaluate them on this partial matrix, what do we find? Indeed, the original languages seem harder. So that's nice. We've recovered what everyone thought was true, but we kind of messed something up. Does anyone see what we messed up? I don't necessarily expect you to, because it took us like a day or two until I went like, wait a second. But if you do, unless you've seen the talk before, pretty interesting. The thing we messed up lies with the fact that I said we took the models that we trained before. So we trained our models on the original training data, which is part original and part Translationese, but it is always more Translationese than original, right? Just because we have 21 languages, we are of course going to have more training data that is translations for any given language, even for English. Even for English, less than 20% of the sentences are natively spoken in English. So every one of those 21 language models has seen mostly Translationese. Well, of course, it's going to find Translationese easier. So this experiment is not good enough. We need something better. And so that's this experiment, where we actually change the training sets. We can only do this for one language at a time. So in this case, if we want to change the training set for English, what we do is we remove so many translated or original sentences until we have exactly as many original as translated sentences in this training data set, which makes it smaller, but not impossibly small for languages like English or French or German, which still have like 10, 20% original sentences in the data. And so we can do this for these languages that have enough data, run the same experiment that we did here, again, with a partial evaluation, that's fine. But now that our training data was balanced, it actually turns out the difficulties are now the same. And this says native is easier, but I mean, look at this variance, this is nothing. So really, there's nothing that makes Translationese inherently easier than native text, nothing that makes it inherently less informationful, less complex, which is interesting because it contradicts what we thought before. But we did find that it is markedly different, because otherwise these would have looked the same also. And so that's I think one of the main reasons I love this paper, because this was a really fun experiment to really figure out how to get it right. So in conclusion, yeah, it's fucking tricky. Make sure your training data is comparable and fair. Make sure your metrics are comparable and fair. Only use open vocab models. The time of closed vocab is over. And make sure your stats are fair. No p-hacking, please. And then it would be nice if we had more languages, but everyone wants to have more data for more languages. So I think I'm preaching to the choir here. Yeah, and so that's it for the results of the language modeling. I think this is another good time for questions.